Good morning, Math 3. I hope this video finds you well, and maybe you'll get outside today to enjoy the very cool sunshine. It is a colder spring day for us today and tomorrow, and then next week it looks like May will start feeling like May is usually supposed to. We are finishing up our week looking at linear and non-linear equations. Linear equations make lines. Linear functions make lines, right? Tables of points that appear on a line can be generated by a linear function. So just like when we talk about decimals, percents, and fractions, and we arrange them on a triangle together, we can do the same thing with a linear function, with a table, and with a graph. They are 3 points of a triangle. They all relate directly together. So in Khan Academy, today, tomorrow, sometime this weekend, it's due Monday, you're going to take a look at some tables. You're going to take a look at some graphs. You're going to take a look at some linear functions and some nonlinear functions and try to learn how to tell them apart. There's several videos, right? Recognizing linear functions. Here's the table one. Here's the word problem one. The missing value one. 4 different ways to look at functions and start to do that identifying. There's also an interpreting a graph example before you get to that second interpreting the graph's activity, right? 2 activities, 2 practices, and I'd like to see a screenshot of your score at the end of each one. Remember, we're going for 85% or better, but if you need to try more than once, fantastic. If you're trying 7 times, it's too many. Stop beating your head against the wall. 3 is the magic number. See if you can get to 85% or better in 3 tries with these activities. And watch the videos as much as you need to. I'm going to cover an example right here so you have my explanation as well. So let's take a look. We got a pretty standard question about tables, graphs, and functions. Could the table of x and y pairs, they're right here, right? X's and y's, have been generated by a linear function? My favorite way to answer this, you all know, and I'm going to show you anyways, is to go and make a math picture, right? Free, beautiful math. Let's start graphing. And I'm going to bring my points over, and I'm going to put them on a graph, and I'm going to see if it looks like a line. That's really what the question is answering, right? Could it have been generated by a linear function? If it's generated by a linear function, it has to look like a line. There's no 2 ways about it. It's a yes or no question. So let's give that a try. 0, -6 would be our first point. We're going to put in a table. 0, -6. Our second point, 1 and -3. And we're going to find out real quick here. This is going to start to look like, oh, there it is. There's 1, -3, 3, and 0. And finally, 5 and 4. And we might need to zoom out here just so we start to get the whole picture. Hey, look at that. Very, very interesting. If I want to go a step further, if I want to test my theory, I can actually mess around with adding a linear function and seeing if I can get it to go through all of those points. Okay. And that's going to take the form of y equals mx plus b. So I'll start with the y equals. This line is going to have a positive slope. It's going uphill to the right. So it's going to be a positive factor of x. Let's try 4x just for fun. 4x looks too steep. Let's try 3x. 3x looks closer. 2x, even better. All right, 2x. And then to move it over, I have to change the y-intercept. Now, if I change the y-intercept, right now it's at 0, right? Watch, I'll put in plus 0, and the line stays the same. If I change it to plus 4, the line is going to slide up on the graph because now I'm telling it to go through the point 0.04 on the y-axis. That's not what I want. So I think I'm going to subtract a b as a way to slide the line down and see if I can get it to... So let's trace here and estimate. I think this is going to pass through at about 4.5. Let's do negative 4.5. Close? Maybe? 4.9. So we're getting closer, and I think we need to adjust our slope a little bit. 2.2. Oh, too steep. Let's go 1.5. Too shallow. 1.7. Hey, 1.7 is looking pretty darn good. 1.8. Even better. And now we start to see a pattern. Right? I have a line touching 1, 2 of the points, but 2 of the points are missing. And if a linear function created all of these points, then they all have to touch the line. Now I can keep fine-tuning my function up here one way or the other. I can tip the line, I can shift the line, but I'm looking at this and I'm thinking, you know what? There's no way I can create a function that's a line that will go through all 4 of those points. They just don't line up. And so based on that, I'm going to come back to this table and I'm going to say, could this table have been generated by a linear function? No. The points don't line up. Let's see if we're right. I love that sound. Okay, this is the thinking process. This is the testing process that I want you to try to go through with each of your problems. Go visit Desmos as much as you need to, or draw your graphs by hand. That's just fine. That's lovely. You can use the app. You can use the web-based version, but build the tables. Try and build a y equals mx plus b function to test your points, if that's helpful to you. But one way or the other, you need to decide, hey, is this a line or is this not a line? Either way, it might be a function, but in this case, you're looking for linear functions, functions and tables that create the graph of a line. Make sure to ask lots of questions, do good work, and I look forward to seeing your answers.